Let's learn how to write the formula of a coordination compound from its IUPAC name. Here, first you see an IUPAC name of a coordination compound. Now you can write the structural formula from this IUPAC name. Now how can do this? First step, you give the coordination sphere like this, and next step you find the metal, that is central metal atom. Here the central metal atom is cobalt. Now write the cobalt, and oxidation number is 3. You put the oxidation number. After then you put the ligands one by one. Here first is tetraamine, that is here I put the tetraamine, 4-amine, and next one is the aqua, that is the water, and after then it is chloride. Okay, all these are the ligand, and remaining one is the chloride, and this is chloride is the counter ion. But here we don't know the number of counter ion, therefore we consider it as X, and now you have to find this X. Now how can you find this X? First, now in this here you know the oxidation number of this central metal. Central metal oxidation number is 3 plus 4 into 0, since ammonia is a neutral ligand, and plus to water is also neutral ligand, for is 0, and for chlorine it is -1, and for this chlorine it is a -1. X into -1, this is equal to 0. Then x equal to 3. Therefore the final formula of this coordination compound is CON is 3, for this is water, then chlorine like this Cl3. This is the final. Next one is Diamminechloridonitrito-N-Platinum 2. Similarly, first we write the coordination sphere, and the next you find a metal. Here metal is platinum. Write the platinum. Next is the oxidation number is 2. Now see the ligand diammine. Write this diammine, chlorido Cl2, nitrito N means NO2, and that's all. Now you don't know the charge of this coordination sphere, therefore you give it X, and now you have to find the X. Now how can you find the X? Therefore here this coordination oxidation number is 2 plus 2 into 0 plus -1 plus, and for NO2 oxidation number is -1 equal to X. Now you will get X equal to 0. Therefore the final formula will be platinum, and is 3,2Cl NO2 like one. Potassium tetrahydroxidozincate 2. Now here similarly first you put the square bracket. After then the central metal is zincate. Therefore for this you zinc, and its valency is 2, and here tetrahydroxido means ligand is hydroxido, therefore O is 4. Now here is potassium. Potassium is not ligand, but it is a counter ion which is right before the ligand, and it is present left outside this coordination sphere. Therefore we write potassium here, and but we don't know the number of potassium, therefore we consider it is as X. Now we have to find the value of X. Now X into 1 is the valency of potassium, plus 2 is the valency of zinc, plus 4 into -1 is the valency of hydroxide ion, and made it equal to 0, and calculating it we get X equal to 2. Therefore the final structural formula will be K2ZnOH4. Dichloridobis ethane 1,2 diammine cobalt 3 chloride. Similarly, first you give the coordination sphere. Next you find the central metal. Here central metal is cobalt. Its oxidation number is 3. And now ligand are dichlorido means Cl2. Bis ethane 1,2 diammine. Ethane 1 short form is En. For this ethane 1,2 diammine short form is En. Bis means there is two ethane 1,2 diammine ligand. This is a complex ligand, therefore bis word is used, that is bis means di, and therefore 2. And after this oxidation number, chloride is written. Chloride is written after this oxidation number, therefore it is not the ligand, it is the counter ion present right outside the coordination sphere, like this. But here we don't know the number of counter ion, that is chloride, therefore we give it X. Now we have to find out this X. Now how can you find that? This is 3, oxidation number of cobalt is 3 plus 2 into oxidation number of chlorine is -1 plus 2 into oxidation number of En is a neutral ligand, therefore 2 into 0 plus X into -1 and equal to 0. Calculating this, we get X equal to 1. Therefore the final structural formula will be COCl2 En2 Cl2X. Tetracarbonyl nickel 0. Similarly, we give the coordination sphere. Here central metal atom is nickel and ligand is the tetracarbonyl, means there is 4 carbonyl, therefore CO carbonyl for CO, there is 4, that's all. But we have to find the X, means surge of this coordination sphere. Now we find that the oxidation number of nickel is 0. Therefore 0 plus carbonyl is a neutral ligand, 4 into 0 equal to X, therefore X equal to 0. Therefore final structural formula is NiCO4. One iron 3 hexacyanidoferrate 2. Here similarly as before, first you give the square bracket, after then here central metal is ferrate, that is iron, and its valency is 2. Ligand is cyanidor, hexacyanidor, therefore CN6. Now here iron 3 is the counter ion which is written before this before the ligand, therefore and it will present outside the outside the coordination sphere, therefore I put iron 3 here. Now in previous classes you have found, suppose AB is a compound, a valency of A is X and valency of B is Y, and then valency of X sit near B and valency of B, that is Y, sit near A, that compound will be AYB6. Similarly in this compound also, here there is 2 parts, one is this iron and other is this coordination sphere. Now valency of iron 3, that 3 will sit near the coordination sphere, and while the valency of this coordination sphere it is unknown, and we consider the valency of this coordination sphere is X and put it near iron 3. Now we have to find out the X value of X, and this way thrice X, 3 means the valency of iron, thrice X plus 2 means valency of this iron, plus 6 into -1. -1 is the charge of cyanide, and whole is value is multiplied by 3 for this 3 and made it equal to 0, and calculating this we get X equal to 4, and final formula will be Fe4 FeCN6 3.